On this episode of DevKit Weekly, we're reviewing the ISP2053-AX evaluation board from SiP. Bluetooth has permeated the audio market, from speakers to earbuds to hearing aids. As consumers, we now have some pretty clear expectations of Bluetooth-enabled audio products like high fidelity, decent range, and lengthy battery life. To help tailor the ubiquitous wireless technology to the requirements of modern consumer audio, the Bluetooth SIG released Bluetooth Low Energy Audio in the fall of 2020. It adds new features to Bluetooth Classic Audio, such as the Low Complexity Communications Codec, or LC3, a low-power audio codec capable of delivering high quality at low data rates, and therefore minimal energy consumption. Also new is multi-stream audio, which allows multiple synchronized but independent audio streams to be transmitted between an audio source and one or more sync devices, as well as Auracast Broadcast audio, a new audio sharing capability that basically extends multi-stream to an unlimited number of audio sync devices as well, and that could be either on a personal area network or location-based in something like a theater or gym. And now we're starting to see products that support that Bluetooth Low Energy Audio capability come to market. For instance, the SiP ISP2053-AX evaluation board is a development kit for the ISP2053 system and package that's based on the Nordic Semiconductor nRF5340 Bluetooth 5.2 wireless SoC. The ISP2053 packages that advanced dual-core Bluetooth SoC in this 8mm by 8mm by 1mm module, with everything else you need to get connected audio applications off the ground. That includes decoupling and load capacitors, 32 MHz and 32 kHz crystals, DC to DC converters, an RF matching circuit, and even an antenna. Not only does this robustly integrated SiP help connected device developers accelerate time to market by hopscotching a bunch of that low-level hardware design, it's also a big win on the procurement front, especially today with so much supply chain uncertainty, as you get to source all of those components from a single vendor. The nRF5340 at the heart of the ISP2053 was designed specifically for Bluetooth 5.2 applications and brings two ARM Cortex-M33 CPUs to bear on connected audio applications while delivering an ultra-efficient power consumption score of 101 core marks per milliamp. The chip natively supports traditional Bluetooth Low Energy, Bluetooth Mesh, and other IEEE 802.15 wireless PANs like Zigbee and Thread, as well as ANT+ wireless sensor network connectivity and NFC, the last of which even benefits from an onboard NFC antenna. And of course, it also supports BLE audio at throughputs of up to 2 megabits per second. To get developing BLE audio applications with the kit, you'd use Nordic Semi's NRF Connect SDK, which packages the Zephyr RTOS and all the libraries, drivers, and protocols you'll need in one single environment. To get that interface with your ISP2053-AX target, you just connect the test board to this larger interface board using the provided ribbon cables, power up the stack through the barrel connector here, and connect it to your development PC over the USB port that's just on the interface board. Once that hardware setup is complete, you can use an example nRF5340 audio application in the Connect SDK, which demonstrates things like audio playback over isochronous channels using that new LC3 codec for compression and decompression. The example application can be used to help prototype connected isochronous streaming or broadcast isochronous streaming modes between BLE audio gateways and headsets, where the gateway receives audio from an external source via USB or I2S and transmits it to one or more sync devices. But regardless of whether you're developing either a gateway or a headset, both are required for this application example. The problem is that both require different firmware. The good news is an included build.prog.py Python script is included to simplify building and programming the firmware. When you're ready to build off examples like that, you can use the header pins on the I/O board or these pins on the test board itself to add on hardware. A debug connector permits use with Nordic development kits, while the interface board includes an onboard J-Link JTAG and serial wire debug emulator, enabling use with J-Link programmers. So if you want to get tuned in, get it. You can pick up your own Insight SiP ISP2053-AX development kit from the company's website for 179 euros. That's $181.39 for those stateside viewers. Or for those of you who are cost conscious, you can enter this week's raffle by filling out the form that's linked to on screen and in the description below to win this kit in my hand for absolutely free. Once you have one, you'll be on the air in no time and may even want to check out some of the additional capabilities we didn't have a chance to address today, like the angle of arrival and angle of departure that can be used in direction finding use cases. Again, all of that is at your fingertips with the NRF Connect SDK and an eval board like the Insight SiP ISP2053-AX. As always, thanks for watching, and we'll see you next week on DevKit Weekly.